Good afternoon. Today I'm going to show you how you can use Artworks Tagger and Wirebond program to create a bond document. And we're going to start with a dumb package drawing. We're going to add intelligence to it, then we're going to drop in the die, get it wired up, and then we're going to extract a netlist based on the wirings that we placed. So to start with, let's start with the package side. We're going to run a Tagger program, and to do that we go to New Project. And now we select the name of the package drawing that we want to tag. In this case I'm calling it QFN 10 by 10. We have to put the units that the package was drawn in this case it was micron, so we click OK. It gets dropped in there. And let's look at this a little bit. If you'll notice, it's basically just a bunch of lines, you see, that form the fingertips where we want our bond to land. It has a paddle for the die. We call this a die paddle. And I've created a zero width close polyline on a layer called VSS because that's going to define where my down bonds go, and I want to use that as kind of the edge reference for my down bonds. And that's about all I've done. It came from actually a package manufacturer's bigger drawing that I extracted. So what Tagger is going to allow me to do is to create little targets at the end of each finger, and I'll number those targets, and I'm actually going to do one more step which I don't normally do. I'm going to import a file which is going to give each pin a net associated with it. That file, probably comes from a system engineer who says that, pin 1 is VSS, pin 2 is clock, pin 3 is, IO1 or something. And we're going to do that so that when we do our net out tracing, we can report in terms of nets and not finger numbers. That's more intelligible to people that are interpreting the net out. Okay, so to do this we're going to run the routine called tag fingers, and it says no, we don't need to do that. And these are lines, so we're selecting tag lines. Now this distance is how far back we want the target center to be from the tip. I've selected 100 microns. And now we're going to draw a number of fences that help the program find the tip. So I click Add, I zoom in, click here, zoom in on this side and click here, and you see a line's been drawn that crosses all of the fingers, but it has to be on the outside of that tip. Now I'll add another one for this bottom part, and then I'll add another one for this right side, and I'll add the last one for the top. So it's not important how far back you go as long as you're outside the center. Okay. So now that I've got my 4 guys, I just click OK, and the program found 84 fingers, which is good. That's how many I know that I have, 84. And you'll see how it created the targets. It measured from here out back to 100 and drew this perpendicular to here, and this is the actual target, this little circle. It's actually a block. Now what we're going to do is we're going to number those so that each target has a pin number associated with it. So this will be 1, 2, 3, 4. So we go again to Tagger and we select BF num, and this is the block that was created. So we're going to number that block. We're going to go counterclockwise. We're going to number them radially from the origin, and I'm going to say that this is my finger 1 here, and in less time that I can blink it's numbered all of the fingers. Now each one of these is a block with attributes. The attribute for the finger number is 1, but it doesn't know what net it is. So we have a very specialized module we added to Tagger, and it's in the utilities, and it's called import attribute. So it asks me what file do I want to import. Well, I have prepared a text file that has the bond finger number followed by the net. Let's open that, and you can see in column 1 I have the bond finger number from 1 through 84, and in column 2 I have whatever net is associated with that bond finger. And so what I say is column 1 attribute would be the finger, column 2 attribute would be the net, and I want to update column 2. I just click OK, and now it's done. How can I tell that worked? Well, if I do a list on, say, one of these guys now, you see it's a block, you see the block name, and you see the block has some attributes. For example, the die pad attribute is empty, the ball pad attribute is empty, the finger is 8, and the net now is pad VDD 1P8 RX4, and that's what came from that table that I just imported. So you can create that table using Excel. All right, so now I've got an intelligent or tagged package drawing, so I'm going to save it. And I'm going to call it QFN 10 by 10 underscore tagged, and that's how I know that it's been tagged. All right, in this next step, I'm going to use Wirebond to create my bond document. But before I start the Wirebond, I need to prepare two pieces of data. The first data is what we call an Aif file, but it's really just a text file. And this describes my die. And this file can be created by scanning a GDS2 or by building it in Excel. You can see it's called Aif here at the top. It defines the size of your die and the name. It defines any pads that are used for the die pad openings. And then the most important part is a netlist. The first item is the net name, die pad number, the pad stack, which we defined previously, and then the center of the die pad, X and Y. That's it. So this particular die has 241 die pads on it. And you notice there's no information about where it connects or anything like that, because that's not really part of the die description. To tell our program where we want to connect these die pads, we use a separate ASCII file. I'm calling it Merlot pad connect.txt, and it has two columns. The first column is a die pad number, 1 through 241. Now the second column has either the finger number of the package, you see that pin 1 goes to 84, or it has a name of a ring that I want to bond down to. In this case, in the package, I called my ring VSS. So this has to match the name of that ring layer. And it can also have either a dash or an NC indicating that's no connect. So die pad 5 is a no connect. Die pad 4 goes to the ring VSS, and die pad 3 goes to 84. Now with those two files prepared, I can run the Wirebond program. Again, I start with a new empty drawing, and I go Wirebond and a new project. Here I specify the units of the package. Here I specify the package that I want to use, the tagged one, because it's a smart one. Here I tell it the Aif file that represents my die, and then I just click OK. Now when I go to place my die, I can move it around, I can rotate it, I can mirror it. I don't need to do that. I'm just going to place the die. Okay, do I need to verify wire tier definitions? You only need to do that when you have die pads where the pad is confusing where it's on the top or the side, so I don't need to do that. Now I need to do my wiring, and I'm going to go to my SmartWire module. Now SmartWire has two tabs. Tab on the left is for setting things up. You got to tell it what layers things are on. Well, the die pads are on layer die pad. The fingers are on layer finger pad, and you have to define which layers represent rings, in this case VSS. The diameter of the wire, spacing for multiple spaces, how far from the edge. This one's important. I have 110 microns and I have it positive. That means that my wire is going to land 110 microns in the positive direction away from the edge of my ring there. So it should be roughly in the middle of the area that's been indicated for wire bonding. And I'm putting a ring marker to mark all of the down bonds, because that's how we can trace the nets. So click on die pads, 75, okay, all these units are in microns. Now I come to the connection rules. Now I'm going to click on connection list, and I'm going to select the file that I want to connect, and now okay. And you can see, based on that file I prepared, it creates a rule telling me which die pad goes to which finger, or if it goes to the ring with VSS, or if it's a no connect. So I should just be able to click OK now. And you can see it's placed all of my my wires. Now it's possible for the ground wires sometimes to be where you don't want them to be, and it's certainly permissible to move them around. For example, if I want this ground wire in closer, I select the wire and its accompanying target, and I just can move them, say, to there. So that doesn't disturb the connectivity as long as the end of the wire falls in the center of that target. Okay, so you can move wires around if you like. And you can see we have some double bonds and triple bonds to the same package finger. Now the next step I'm going to do is create a netlist out from this to make sure that these things actually go where they supposed to go. And the way the netlist program works is it usually starts at the die pad, and then it looks for a wire that lands on that die pad, and it follows the other end of the wire, and then it determines whether it falls onto a finger or whether it falls onto one of these targets, and it generates a report as to what it found. If it has a pad like this and there's no wire on it, it'll basically follow it nowhere, and it'll still spit that out in the report. So we're going to generate a little report here now. Let's do this. We go to Wirebond and we go to net out, and we got to help it out a little. We got to tell it that the wires are in layer wire. Now here we have to identify all the die pads. In this particular case, because of the chamfering of the die pads, instead of being just one square or two rectangles, there's a number of different die pad polygons, but they're easy to identify because they start with DP. This is our bond finger. This is our ring bond block that we built when we dropped them down on the ring. We need that. We don't have any ball pads. And here we define what we want in our report. So the first column, I want the die pad by die pad number. Then in the second column, I want the die pad's net name, and that's the net name that was under the pad when we created the Aif file. And then the third column, I want the bond finger, but rather than put the bond finger number, because that's not that clear to some people, I want the bond finger net name. All right, and we got that net name because we did an attribute load when we tagged the package. Finally, for the ring bonds which don't have a net name, we're going to use the ring bond finger number, which will actually have that VSS incorporated in the name, so that'll help us out there. All right, we have some snapping values. I want all no connects to appear in the output, and I'm going to sort by column 1, so I just click OK, and I'm going to call it Merlot Netlist Extraction Report. It tells you when it was generated, and sort on column 1. So let's look at these columns. Now, column 1 is our die pad. Column 2 is the die pad net. So that came from the die. Now column 3 is the finger net, which is a good thing. What this is telling me is that die pad 1 that has net VDD lands on a finger that's also been assigned VDD, and there's no ring bond. Okay, so you can see these guys all are VDDs. Then die pad 4, which is VSS, does not connect to a finger, but it connects to one of those little guys labeled VSS, as you can see. These other things are generated to make that unique, but basically we know it hits the VSS ring. And you can see die pad 5, which was a no connect, connects to nothing. These were actually generated not by any kind of table. We actually started at the die pad and traced through the wire to either the finger or to the ring. So this is actually based on what we physically drew and not on any kind of preconceived input data.